Hello. Now, on Monday, I sent you a 34 multiple choice question worksheet, which was there to help you revise your elements, mixtures, and compounds. You're going to need that in front of you for today's video. Also, in the class charts that I've sent you today, I've also given you a worksheet that's going to help you revise the properties of metals and non-metals. Because as you might be guessing, we're getting quite close to the end of the unit now, and our assessment is soon to be upon us. Next Monday, there'll be one more lesson teaching you the last part of this topic, which is on chemical reactions, and then it's going to be time for our assessment. So consider this maybe mid-topic revision. It's up to you. Now, if you are sat with the work that I sent you on Monday, you should be able to go along and follow and self-mark and self-correct what's on here. Consider it your green for growth. That's going to be your main task for today. It could take some time. If you really want to push yourself, maybe watch the video without having the work in front of you and then go away and see if you can do it just from memory. That'll be even better. And of course, this video will always be there as a reference in case you forget anything. So let's begin. Now, as I'm going through these questions, I'm not just going to give you the answers. I'm going to be padding it out with a little bit more science, a little bit more revision, and it would be great if you could get that down on your notes. So, question 1. I am a state of matter. My molecules are very close together and hardly move. What am I? Well, the answer is B, a solid. But remember, when we talk about the particles hardly moving, they do move. And there's a word beginning with a V that describes how they move. Hopefully you're thinking that they vibrate. You've got vibration there. So that might be something we just want to add. Particles in a solid, yeah, they are very close together, but they do vibrate. They can't move as in fly around, okay? But there is some kinetic energy there. Question 2, I'm a state of matter. My molecules are jumping all over the place. Well, that's a gas. Now remember, with a gas, the reason the particles can jump all over the place is because they have no bonds between them. They have huge gaps in between the particles, which is also why they can be compressed as well. So remember that. Now, by the way, if you can't make out on the screen, I'm not sure how big these questions are going to end up on the screen. If you can't really see the questions too well on the screen, make sure you've got your sheet in front of you, okay? I'll always read out the question number so you can follow along. Question 3. My molecules move past each other easily, but they are pretty close. B, we are a liquid. And we talked in lesson about, yes, they can move past each other. We use the term they can slide over each other. And the fact that they can slide over each other means that they can be poured, they can flow. So liquids can be poured, they can flow, they can change their shape, yeah, to fit the shape of the container because they can slide over each other. Question 4. If the particles in a substance are arranged in a tight pattern kind of way, the matter must be solid. Absolutely must be a solid. Question 5. I don't think there's much more description needed for question 4. Question 5, which is not in a gaseous state at room temperature and normal pressure. Well, one of the things we looked at in our unit was properties, and we talked about boiling point and we talked about melting point. Now, when we look at properties, or boiling point as a property, that is the temperature at which something will become a gas. Now, a quick Google of these should have told you what the boiling point of each of the elements were. And we would find out that the boiling point of silver is way above that of room temperature. So silver cannot be a gas at room temperature. Oxygen, hydrogen, nitrogen, you may well have known are gases anyway, but a quick Google of their boiling points will tell you that their boiling point is below room temperature. So by the time we get to room temperature, we have boiled and we have become a gas. Question 6, which might have a bit of air in it. Your lungs. Now, an interesting fact about your lungs, if you've ever been lucky enough to dissect some in class, I mean, you can order some from the butchers if you want to do it at home with your parents, nag them to do it with you. You can get some scissors and you can cut a little piece of lung off the scissors and it will float in water because of all the air sacs, all the alveoli that contain all that air inside it. That allows it to float. Question 7. If we cool a liquid down and take energy away from it, the atoms will get closer together and not move anymore. Now that's describing a solid, isn't it? Yeah, if the atoms aren't moving anymore and they're very close together, yeah, they're only vibrating, that describes a solid. And when we cool something down for it to become a solid, the answer is B, that's freezing. Question 8. I am a state of matter. You can't get my molecules any closer together, right? And they have bonds between them, strong bonds. Well, which is a state of matter that can't have the particles any closer together? Well, it's C. It's a solid. I have no idea who Mrs. Meerholtz is for question D. For option D on that, sorry. Question 9. The measure of the average energy of motion of particles is... What a great question. There's a lot to talk about here. When we talk about the energy of a particle, we're talking about its kinetic energy. I can imagine maybe a box in front of me here, and all the particles of air in that box are moving around, they're flying around, but they don't all fly around at the same speed. Like smashing open some pool balls when you're breaking in a pool match on a pool table. All the balls are going to fly around, but they're not all going to travel at the same speed. They all have different amounts of energy, right? That energy we call kinetic energy, movement energy. Now, any one particular individual particle will have its temperature, and that's going to be dictated by how fast it's moving, by its kinetic energy. But if I've got a gas and some particles are moving really quickly and some particles are moving really slowly, we could say they have different kinetic energies or different temperatures. But the temperature of the gas as a whole is going to be the average energy of all those particles. So the answer is D. Question 10, state of change, solid to a gas. Now, you may be looking at question B there, and I know you've all done states of matter at the beginning of this year. And I said question B. What I mean is option B. And you may recognize the word option B, sublimation, as when we taught it as something that goes from a solid, straight to a gas. So the answer is B. But some people also use the term sublimation or desublimation to talk about the reverse. Now in school, we've taught you that as deposition. All right, but just be aware that sublimation can also be used to refer to the opposite movement as well, a gas to a solid, or it might be called desublimation in some of those terms. So the answer for question 10 is B. We skip out the liquid form. If you want examples of substances that will do that, carbon dioxide will do, water even will do that. If you get something very, very, very cold, the water vapor in the air will form ice crystals on something without forming the water droplets first. That's an example of deposition, sorry. Solid to a gas would be iodine. We can take our iodine, we can see it giving off the purple gas without forming liquid droplets first. Question 11. Gas has... Well, it's got an undefined volume. Yeah, it's got an undefined shape. That's dictated by the container it's in. If I've got a really big container, the gas will take a bigger volume. If I've got a smaller container, the gas will take a smaller volume, and it will take the shape of the container. So that's A for question 11. Oh, about a third the way through, nearly. Question 12. The change from a gas to a liquid. So when I've got, for example, water vapor, steam, right, as a gas in the air, maybe I get out the shower and it's really hot. I walk over to my mirror and I see water droplets forming on the cold mirror. It's gone from a gas to a liquid. Now we might say, oh, I've got condensation on my mirror, and hopefully that should lead you to option C. When we go from a gas to a liquid, it's condensing, it's condensation. Think about when you did your distillation for separating mixtures. We had a condensing tube that turned the gas back into liquid as it came down the condensing tube so it could be collected. Remember, we talked about separating ink and water. Question 13. What is not a following of an example of vaporization? Vaporization, as far as we're concerned, really just describes the changing of state as something is going from a liquid to a gas. So a wet pavement drying after the rain will be evaporation. Something is going from a liquid to a gas. We would class that as a form of vaporization. B, bubbles forming as water boils. Right, that water turning into a gas, we'd class that as an example of vaporization. D would also be evaporation, so a type of vaporization. C is the opposite. Yeah, condensation. So C is not vaporization. So you may not have been familiar with that word. Hopefully you are now. Question 14. Matter in which state has both a definite shape and a definite volume? Well, it's a solid shape. So for example, if I take this phone here, right, I can shake it around, I can turn it around, I can put it in one hand to the next, but it's still going to keep its shape, still going to keep its size. If I had a cup of water and I was swishing it around, its shape would constantly be changing. And if I had some gas, then, you know, I was going to change the size of the container it was in. Maybe it's in a balloon and I'm squeezing the balloon or stretching it open. It's going to change its volume. So if something has a fixed volume and a fixed shape, then it's a solid. Question 15, an element. Now, we had a few definitions for an element, and I said to you that an element was something which was made of just one type of atom. So let's have a look at what the options are here. The basic particle of matter, a substance formed from the chemical combination of two or more elements, the force that holds two atoms together, or D, a frog. Well, it can't be D, obviously. It can't be C, because that represents bonds. And it can't be B, because we know a combination of two or more elements is a compound. So the answer here, by elimination, it has to be a basic particle of matter. Although I would suggest that an even better answer for that would be an atom. Or an even better definition for A, the basic particle of matter, would be an atom. Our definition of an element being made of just one type of atom, I think, is even better than the definition we are given there. Question 16. A compound. Well, we've talked about this. We said a compound was a mixture of different substances that are bonded together, and that is answer B, a substance formed from the chemical combination of two or more elements. So we might need to know some examples of compounds for the assessment. We might need to know that water is hydrogen and oxygen. We might need to be able to use the formula H2O to know that there are two atoms of hydrogen and one atom of oxygen. Or in carbon dioxide, CO2, that there are two atoms of oxygen and one atom of carbon. So your answer there is B. 17, must be halfway now. A substance whose particles are close together but move freely around one another. Okay, so this is very similar to what we had before. If they are moving around one another, sliding over each other, but they're still close together, we said that was a liquid. And remember, we're repeating ourselves now, it's important, it's that allows the liquid to flow. It's that ability of those particles to slide over each other that allows that liquid to be poured. Question 18. Unlike a solid, liquids and gases will. This should be getting easy for us now. They will both A, take on the shape of the container. Now, B, keep its volume in different containers, is only going to apply to a liquid. I can take a liquid in a small cup and I can pour it into a bigger cup, but the volume of that liquid won't change. But if I take a gas in a small bottle and I put it in a big bottle, its volume will. C only applies to gases. And D, keep its shape in different containers. Well, that's only going to apply to solids. They're the only ones that keep their shape. Question 19. When a liquid is heated, what happens when a liquid is heated? Well, the particles, when anything is heated, they gain kinetic energy. Remember we said before that the speed that particles are moving is directly linked to their temperature. So if I'm heating something, increasing the temperature, those particles are going to be moving more rapidly, which is your answer D. They're going to be moving faster. Now the thing is, if they move fast enough, if they get enough energy as they are moving, then they have enough energy to rip apart or overcome those bonds that hold the particles together, and that's when the liquid will boil. Those particles are suddenly moving fast enough and they can rip apart and they're no longer bonded together. If we're talking about melting in a solid, those vibrations could become big enough to rip those particles apart so they become a liquid. Anyway, the answer there was D for 19. Now, because I'm only able to upload videos that are 15 minutes or shorter to this YouTube site, I've had to split this into two parts. So for the rest of this, go and have a look at part 2.